Welcome dear students. As part of your survey lab, you are supposed to know some basic concept regarding this leveling. You will study about the details or detailing of this leveling in your coursework on survey. But before that, I'll give you a small introduction on this leveling. You are supposed to know certain terminologies before you start doing the numerical or before you start to know the concept of this leveling. First one is called as your reduced level, denoted by RL. It is the elevation of any point measured with respect to the mean sea level or datum. That is, if I am saying it is a particular point is 10-meter height, I have to say with respect to a datum, that is, I have to say with either with respect to the ground level or with respect to a point, this is at 10 meters height. So we consider the mean sea level as the datum for any point reference. And the term benchmark means benchmark is any station or point of non-RL. That is, the elevation of that point will be known to you. RL of any point can be found using RL of benchmark. That is, suppose when you are traveling in a hilly station, you could see the markings on the side of the road saying this is at a height, this point is at a height of say 1000 meters above the mean sea level, which means from the mean sea level the particular point which is situated at that marking is at a height of 1000 meters. And you can see the benchmark are generally defined by this well-established organization like Survey of India or any other organization like the Indian Railway, the PW, Public Works Department, Central Water Commission, Airport Authority of India, National Highway Authority of India, etc. We could start our survey work with respect to those established benchmarks. And the mean sea level data in India is taken as the data of 19 years sea fluctuations considered at Mumbai High. Everywhere in India, we take the mean sea level with respect to a portion at Mumbai High, a place called as Mumbai High in Maharashtra. Next terminologies are backside reading. All the first reading taken from instrument position are called as backside reading. That is, I have set a instrument at a certain point and I am taking the reading from that point. The first reading taken is called as your backside reading. All the last reading or the last reading taken from an instrument position is called as your foresight reading. The foresight reading, either we take the foresight reading when the instrument is to be shifted or when the surveying is finished. And intermediate sight reading means all the other readings except backsight and foresight in a survey or in a leveling is called as your intermediate sight reading. Methods to find the reduced level or the elevation of a point. We have generally two methods. First one, that is height of the instrument method, and the second one, the rise and fall method, which we'll discuss in detail. The first one, height of the instrument method. I'm having an instrument being set over here. I'll do all the initial setting, the elimination of parallax, the leveling and all. After that, once I have done this, the line of action of this instrument will always be parallel to your mean sea level. Unless I change the point or unless I do any alterations to this particular instrument at this point, the level of this instrument will be parallel to your mean sea level, which is considered somewhere here. That is your datum. Now you have your benchmark. Say this is my benchmark, whose RL is known to you, with respect to this, say this mean sea level. So this RL value is known to you. RL of BM is known to you. Now what I do is I will have a leveling stuff which is generally 4 meters high. This is having 4 meters and the least count of this is 0.005 meters, or you can say this is 5 millimeter. So what I do is I will place the first instrument or the first reading over here. From this station point, say S1, I will take the reading, and the first reading, as we have seen, is called as your backside reading. I'll side towards this. I'll take the first reading called as your backside reading. The height of the instrument, now I can say it as the height of the instrument, which is denoted as HI. At this point, S1 is nothing but RL of BM, which is known to you, plus the backside reading which you had taken from that particular station point S1. Now if you want to find, say there is another point A, here. I want to find the reduced level, then I can simply leveling stuff over here. I'll get the value for my reading. Similarly, if I want to find it at another point B, you can just simply keep my leveling stuff over here. I'll get the value for this. So this reading which is taken in between is called as your intermediate site reading, and this reading which is taken at the last, say this is my last point, is called as your foresight reading. So RL of any point, I can write it as RL of any point from this station point. I can take it as what? You have your height of the instrument at this point, which is now known to you, minus, if I height of the instrument minus this reading is your intermediate site reading, I'll get the RL of this point, right? Similarly, you have the height of the instrument here minus this foresight reading, which is nothing but this, will give you my RL of this point. So in general, I can write RL of any point is equal to height of the instrument minus either intermediate site reading or foresight reading, right? And we have a check for this. Once you have completed all the survey, you can do a check for this one, that is check sum of backside reading minus sum of foresight reading must be last RL, that is last reduced level, minus first reduced level. The second type of method to find the reduced level of a point, as you can see, is the rise and fall method. You could see the benchmark reading, I have taken it as the backside reading, then the intermediate site reading, the foresight reading, which means the procedure in the field is same as that you are doing it for the height of the instrument, only the calculation part is different. So here I will have two terms, that is either rise or fall, which is nothing but your previous reading minus current reading. Positive, it will be rise, and if it is negative, it will be a fall. And your RL of any point, I can write it as RL of any point is equal to the RL of previous point plus rise or fall, and if it is positive, that will be rise, and it is negative, it will be a fall. I'm having a point like this. The difference between the previous reading means I have taken with respect to I want to find the reduced level of A, then the previous reading is the backside reading and the intermediate side reading. So the difference of these two will be actually this delta 1. So that will be here, you could see the profile of this. So definitely this will be a negative, which means this is a fall. Similarly, I have the difference between these two readings, say these two readings, this is delta 2. This will also be actually a fall, because you could see with respect to A and B, B is in the lower, which means delta 2 will be a fall. So reduced level at any point is reduced level of the previous point, that is benchmark, minus delta 1 will give you the reduced level of A. Similarly, reduced level of B, in order to find the reduced level of B, I have the reduced level of A minus delta 2 will give me reduced level of B. So you can continue like this, and you can find reduced level of any point, and the check provided for this, sigma rise minus sigma fall is equal to last RL minus first RL. Now we have one more case, that is when sometimes the leveling stuff is inverted in leveling work to get the reduced level of any top point, that is suppose ceiling point or bottom of a roof, etc. Then inverted staff reading is generally taken, and you could see I have set up the instrument over here, done the leveling, done the initial setup, which means now the line of sight is perfectly horizontal. Now with respect to the benchmark, say this is my benchmark, I have taken the staff reading, I got the staff reading like this. So this is my backside reading. Now I want to find the reduced level at this point Q. I want to find the reduced level at point Q, means which point I require to find the reduced level. I need to keep the 0 of my staff at that point, such that the staff reading 0 is here and the 4 meter is here, and this reading I got, say this is my foresight reading. Then your height of the instrument is RL of BM plus the backside reading, same as the case of previous one. Now the RL of this point Q, that is the point at the bottom of your beam or bottom of your roof is nothing but, as you could see, that is the height of the instrument plus this reading. This reading is actually your foresight reading, that is I can write as plus your foresight reading. So that is general case for finding the reduced level of the point either by height of the instrument method or rise and fall method. Thank you.